So, today's lesson is on series. So we're first going to talk generically about what it means when you say the word series, and then we're going to specifically look at arithmetic series, and from there. So first of all, what is a series? So you know a sequence is a set of ordered numbers. A series is the sum of a set of ordered numbers. For an arithmetic series, it has to be finite. It can't be infinite because you can't add something that way, or you could just say the answer would be infinity, I suppose. So if you have a sequence, so let's say your sequence was 2, 4, 6, 8. Who do you appreciate? The series then would be adding that sequence. So 2 plus 4 plus 6 plus 8. Now, if you had an infinite series that goes to infinity and beyond, then there's no way to actually add it up, right? Like the answer is infinity, right? It just keeps expanding like the universe. So, do you see the difference between a sequence and a series? And it doesn't have to be arithmetic. So we're going to talk about geometric, though it could be anything. If you have a sequence, as long as you add all the terms, then you've just done a series. When it's arithmetic, we are going to have a formula that we're going to use to make it quick, so we don't go 5 plus 7 plus 9 plus 11 plus, kind of thing. Okay, so can you find the partial sum for each given sequence? So if I'm going to do this, I have to add up to how many terms? 7. So right now I have 2 plus 6 plus 10 plus 14 plus 18. How many terms do I have to begin with? 1, 2, 3, 4, 5. How many more do I need to come up with? And can you see that it's arithmetic? Why is it arithmetic? Because there's a common difference. And what is the common difference? 4. So I'm going to add 4 each time. So the last two terms are 22 and 26. So I'm going to let you use your calculator. Can you add that up for me? What happened? 98. The next one. 1 plus negative 2 plus 4 plus negative 8 plus 16. So I ask an important question. Is this series arithmetic? Why is it not? There's no common difference, right? So you're right, Chris. Do you see a rule I can use so I can find how many terms do I need? 8. Right? Isn't that 8? Oh, I'm sorry. I'll help you. 8. 1, 2, 3, 4, 5. So I need how many more that I don't have? 3 more. Can you see a rule I could use? Like, how am I going to the next, the next, the next? Chris? Times negative 2? Does that, I think it's right. Can you test it out? 1 times negative 2? Negative 2 times negative 2? 4 times negative 2? All right, you can use your calculator. Can you first come up with 3 more terms? And you can use your calculator. Then add up all the terms. Tell me the answer. Does your intuition tell you, is the sum going to be a negative answer or a positive answer? And if we ended at 64, it would likely be a positive sum, right? So can you add it up? When you see plus a negative, you can just subtract. So 1 subtract 2 plus 4, subtract 8 plus 16, subtract 32 plus 64, subtract 128. Let's see, who might have an answer for me? What did you get? I didn't get that. Thomas. Thomas, be kind. It is negative 85. All right, number 3. So, I want you to find the first 10 terms. And these are not going to be arithmetic, so you're going to have to think what the rule is. And then add them up. Be patient for everybody else. Give everyone a chance. So can you find the first 10 terms? This sequence has an Italian name to it. Do you remember the Italian name I gave this sequence? That's because this occurs in nature. How something grows, like a flower petals and things like that. Yes, this is Fibonacci. So the next one is going to be 13. The next one's going to be 21, 34. When do I stop? Is this 10 right here? Okay. You're allowed to use your calculator. Can you add that up for me, please? That's a good question. So, I'm going to open it up. The question is, how did I get those numbers? Does anyone think what the rule was that I used? So you keep adding the 2 terms before it to get the next term? So like 1 plus 1 is 2. 1 plus 2 is 2 plus 3 is 5 plus 8. So you have to add the 2 terms before, and you do it. Did anyone add it up for me? What? 143. I agree. All right, number 4. Can you come up with the first, how many terms? Oh, they're already there for me. So do I need more? Okay, use your calculator. I won't use my calculator. You use your calculator. What's quicker? Me or you? You, your calculator, me, no calculator. Number 5. See if you can add that series. Number 6, number 7, number 8. And then we're going to talk about something that's called sigma, or sum notation. Sigma is a Greek letter, like pi. So in number 5, I don't have any terms. So if I plug in 1, the answer is 1. Can you cube things all the way up to 5? 2 cubed is 8. 3 cubed is 4 cubed. And I should really put down plus signs. How many more? One more? 5 cubed. And again, I should really put down plus signs because we're adding to make it a series. Can you add that up? Okay, number 6. Can you find the first 4 terms? So if you plug in 1, 1 plus 1 is 2, and 2 divided by 2 is 1. Plug in 2, and you get 2/3. And again, I should be better than that. We're adding. Plug in 3, and it's 2 over 4, or plug in, what are we at, 4, and it's 2 over, so you can use a calculator if you want. The common denominator would have been 30. So if I add that up without a calculator, common denominator, 77 over 30. For your calculators, if you just press enter, you should get a fraction. If you want a decimal, you'd press diamond and then enter, and then it would be a decimal. 7, you're given a rule. Do you know what type of rule this is? We have a name for it, and it's called arithmetic. And why do I know it's arithmetic? Because the rule is linear. And a linear rule means it's arithmetic. How do I know it's linear? Because the degree, the exponent on the variable is 1. And when the exponent is 1, it is linear. So a linear rule means it's arithmetic. Find the first 8 terms and add them. Now the good news is, if you recognize it's arithmetic, you don't have to keep plugging in. All you have to do is keep subtracting 3. You know what I mean? So because you recognize it's arithmetic, I don't have to keep plugging it into the rule. I just know the slope is -3, which is the common difference. So I just have to, once I have the first number, I can just subtract 3. And if it's negative, I'm just going to be subtracting. How many do I have here? 3, 6, a couple more. And then, already you have a sense the answer should be negative. And it's -52. Why did I recognize it as arithmetic again? Because it was linear. And the slope, which is -3, is the common difference. So once you know the first term, you just subtract 3, right? And it makes it simpler, I hope. Number 8. Number 8 is not, it's an uncommon one. So, can you find the first 6 terms? Oops. And if you know something about adding square roots, you could save yourself time by just adding the coefficients in front, right? 1 plus 4 plus 9. What are we at? 16, 25, and 36. So you know they all share the same radical. So we're not adding the radical. We're adding the numbers in front of the radical. 1 plus 4 plus 9 plus 16 plus 25 plus 36. How many root 5s do we have? And the answer is 91. And then you don't have to type in root 5 plus the root 5, root 5, and root 5, right? Like you know enough just to add the numbers in front. All right. Have you ever seen this symbol before? It looks like a fancy E. You see that? Or a sideways M. I'll go with that. A fancy E or a sideways M. Now, that is a Greek letter, and the actual Greek letter is called sigma. And I don't know if you've ever heard that word before. It's a popular symbol for fraternities or sororities. You know how they have 3 Greek letters? Sigma is a popular one of those 3 sometimes. Sometimes it's just called some notation rather than sigma. But what it's telling you to do when you see that, have you ever done a spreadsheet? I think that symbol's there too when you do a spreadsheet and you want to add a column. That you click and you see that symbol. It adds up the whole column. I don't know. All right. So that's a Greek letter. I want you to notice there are 3 parts. There is a number on top. That tells you the last term number. There's a number on the bottom. That tells you the first term number. And then there is right beside it, which is the rule. So if I want to find the first term, what number do I plug in? 1. If I want to find the next term, you plug in 2. And then this tells you when you end. So the last one you plug in is 5. And it's automatically a series, because that symbol means add them all up. Got it? So for how many is that a new symbol today? Can you look at it? Is it a new symbol? Do you think you saw it last year? Yeah. Okay. So the ones that saw it last year, remember, and the ones that think they didn't probably did but forgot? Yeah. Fair enough. We're not robots, right? I don't think. So, can you expand? Can you expand each series and then add it up with your calculator? So, what's the first number I plug in to find the first term? 1. And almost always it's actually going to be 1. Sometimes they get tricky and put in a different number to start with, but most of the time you're going to see 1 on the bottom. So if I plug in 1, what's the answer? And if I plug in 2, you get the idea. And do you know it's arithmetic? Because the rule is linear. Why do I know it's arithmetic? Because the rule is linear. What's the slope for n plus 5? 1. So what am I adding every time? So it's 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus, I don't know when to stop. Do you know when to stop? Do I stop at 14? No, well, the 14th term, but not the number 14, right? Now, add them up. Of course, I have to know how many terms should be here when I count them. There should be 14. And then add it up. And it's 175. Number 10. Can you expand it and then add it with your calculator and tell me the sum of it? Is number 10 an arithmetic rule? And the answer is yes, because the exponent, the degree is, well, what's the slope? Negative. So when you plug in 1, it's negative 12. The next one, you just keep subtracting 12. So then it's negative. Let's see how far you can go. Can you write down the 11 terms, subtracting 12? So I want to know if you know your 12 times tables, in other words. Right? Aren't these your 12 times tables? Like you write them down? So what number should you end with then? 121, right? 12 times 11? Because we go 11, right? So 12 times 11 would be the last one. What did I do wrong? I don't know my times tables. 132. How did I get from 120 to 121? That's something. All right. Use your calculator. Did you confirm, is it negative 792? Did someone get something else? Did you get 92? Yeah. Okay, number 11. Can you look at the rule for number 11? Is that arithmetic? Good. So you're going to have to do it. And what number are you starting with? So you're going to plug in 2 and you stop when you plug in 8. Go for it. So if you plug in 2, it's 2. If you plug in 3, it's 9. Take away 3, which is... If you plug in 4, it's 16. Take away 4. If you plug in 5, it's 25. Take away 5. 6, 36. Take away 6. 7, 49. Take away 7. And then lastly, 8, 64. Take away 8. What do you think? Which one? Which one? It could be me.
I'm writing you pen so I can get the
Oh, okay. Now can you add them all up? Use your calculator. Did I?
Yeah.
I started at 2, 3, 4, 5, 6, 7, 8. I don't need 8 terms. We start with what number?
2.
So you plug in 2, then 3, then 4, then 5, then 6, then 7, then 8, and that's where you end.
Oh, so you wait. That makes sense.
Okay. The bottom number tells you where you start.
Oh.
Like the top number doesn't tell you how many terms there are. It tells you where you end. The bottom tells you where you start. And the top tells you where you end. All right, number 12. So, if you follow, number 12, the rule is not linear. It's not arithmetic. Number 12, what number do I start with to plug in? And you keep plugging in until you get to 6. If you want to know how many terms there are, you take the top number, subtract the bottom number, and you actually add 1. That's called a counting principle. So if you start at 1 and end with 10, how many numbers are there from 1 to 10? So if you went 10 take away 1, you think there's 9 numbers. Right? So you subtract, but then you have to add 1, and that's called the counting principle, right? Like from 1 to 10, how many numbers are there? Well, if you went 10 take away 1, the answer would be 9, which is wrong, as you know. So you have to subtract and then add 1, and that's called the counting principle. Counting. So 6 take away 2 is 4, and add 1, there's 5 terms. So I'm going to plug in 1. What's 1/2 take away 2? 1/2, or I can just write it out. 1/2 take away 2. It's exact negative 1.5. Good thinking. 3 is 1/3 take away 3. Are you good with that one? 4 is 1/4 take away 4. You can just type it in like this in your calculator. 1/5 take away 5. There's a pattern here to write it out. And then I end with 1/6 take away 6. So 1/2 take away 2 is negative 1.5. I don't have to write it as a improper fraction. 1/3 take away 3 is negative 2 2/3. Are you good with your number sense? 1/4 take away 4 is negative. Like, can you take away a quarter? Can you take away like 1/5? And the answer is negative. Can you take away 1/6? Anyway, do you see the pattern? And they're mixed numbers. You could also write it as negative 3 over 2 or negative 8 over 3 and so on. Add it up. And if it's a improper fraction, you get negative 371 over 20. All right, we're going to move on to make sure we get done before the end of the period. Number 13, is number 13 arithmetic? Good, yeah, the answer is yes, and why? Because the rule is linear. What's the slope? The slope is 5. So I'm first going to plug in 4, and I get 27, but I don't have to keep plugging in. I can just keep adding 5. So that's 32 and 37 and 42 and 47 and 52. There's a pattern here, right? If I'm thinking 57, 62 and 67, 72 and 77. No, the last one I need, how many do I need? 17 take away 4 plus 1, 14 of them. But there is a pattern. What did I do?
How do you find the 5? Like, okay, you don't plug in, but how do you find the 5?
So the question is, how did I know it's going up by 5 every time?
Yeah. Like,
And
the 27
yeah. So the answer is, I understand the rule is arithmetic. And why do I know the rule is arithmetic? It's because it's linear. Why do I know it's linear? Because the exponent is 1 on the A. So as soon as I know it's linear, what's the slope? mx plus b. What's m? The slope is the common difference. So since I know it's linear, the 5 already tells me it's going up by 5 every time. Because slope is common difference. I just need to know I ended at the right number. I think I need one more. And there are all of them. Then you add it up. I know you could do it with the calculator. The answer is 833. So I want to make sure it's the setup, right? Can you type it in your calculator? I hope so, right? It's all about the setup. So try number 14. Can you set it up? Number 14. Can you set it up? Number 14. Is it arithmetic? No, not linear, right? To rational, right? Completely different rule. So what number am I going to plug in first to get the first term? 3. You don't have to reduce it down. So like 4 over 6 is pretty. It doesn't have to be a different number. Plug in 4. Don't reduce it down. And it can't be anyways. Plug in 5. Don't reduce it down. Plug in 6. Plug in 7. Plug in 8. And there they all are. If you use your calculator, just go 4 divided by 6 plus 5 divided by 8 plus, you know what I mean? Press enter, it'll be a fraction at the end. So, I know you can do that. 2021 over 560. Using your calculator. Remember, a fraction means you're dividing. So it's just 4 divided by 6 plus 5 divided by 8. You don't even need parentheses because order of operations is already built in. All right, number 15 and 16. Then we're going to talk specifically about the formula we use so we don't have to... Isn't it tedious to write it all out? So for arithmetic, there's a formula you plug in and get the answer automatically. Okay? So it's tedious to write out every term and add it up with your calculator. So we're going to do it 2 more times, and then we're going to say goodbye. Number 15. Now, do you notice something different about number 15? So, do you see that negative 9 over 4? Just put it in front, like that. And then we set it up, and it just multiplies whatever your sum is. So, whatever the sum is, you'd multiply that answer times negative 9 over 4. Is this arithmetic? No, because the rule is not linear. Good. What number am I plugging in first? 1. That would give me 9. Then you plug in 2. Use your mental math ability. Like, 2 squared is 4. 4 times 2 is 8. Did I do it right? And 8 plus 7 is 15. Plug in 3. 9 times 2 is 18. Plus 7 is 25. Plug in 4. 16 times 2 is 32. And 7 more is 39. Plug in 5. That's going to be 50 and 7. And then we end here. 6. That's 36. Do you know how to double 36? 72. And then add 7. Then you add this up. You have to add it up first. Or you can just type it in your calculator like this. It actually comes out to a non-fraction. It's negative 504. Okay, one more. Number 14. Or 16. All I care about is the setup. I know you can type it in your calculator, and if you make a silly mistake, you just try to concentrate to not type something in wrong. Number 16. The 2 in front will just be in front, okay? Is this an arithmetic rule? No. To the third, right? Cube. So plug in what number first? So 1 take away 3. Think. Negative 2. Negative 2 cubed is negative 8. It's a negative answer. Next, plug in 4. 1 take away 4. These are all going to be negative answers. 1 take away 4 is negative 3, and negative 3 cubed is 27. Plug in 4. We just plugged in 4. 5, negative 6 cubed. These numbers are going to get bigger. So we did 4. If we do 5, it's negative 4 cubed, which is 64. There's a pattern here. You're just cubing, right? And it's negative. The next perfect cubed is 125. And if you don't know it, use your calculator and just cube it. Do you remember the exponent button on your calculator? The little arrow above the divide sign? So the next number would be 216, 343, 512, 729. I have to keep going until I plug in 11. And then the last one is actually the easiest one, negative 10 cubed. Because 1 take away 11 is negative 10. And if you cube it, it's just how many zeros? So first, subtract all these and then multiply times 2. And you get negative 6,048. You might make a mistake typing it in. The first one is actually the little negative sign. So when you type in negative 8, you have to use the bottom row. But after that, you can use the subtract sign. So the 8 is the little negative on the bottom row, and then after that you subtract. You use the subtract sign when you have two numbers on both sides. All right, turn the page. We are now on only some arithmetic series. Can you find the sum of an arithmetic series? Now, the good news is for an arithmetic, there's a formula you plug in and it's done. So, that's the formula to add an arithmetic series. You take, how many terms are there? You divide it by 2, and then inside the parentheses, you take the first term plus the last term. AN is the last one. So N is the number of terms, A1 is the first term, and AN is the last term. So you add the first term and the last term, and then you multiply it by the number of terms divided by 2. All right, see if we can use the formula rather than expanding it all. So when I look at number 1, how do I know this is an arithmetic series? It's because the common difference is 3. I know the first term is 7. Do you know how many terms are in this series? And the answer is, how many terms are there? 18. What don't I know is the last term. And if there's 18 terms, the last term is the 18th term. Can you give me a rule so I can find the 18th term? So the common difference is 3, and the first term is 7. So if I want to find the 18th term, can you plug in and find the last term for me? And again, you can use your calculator. So using the rule, the last term is 58. Now we can use the formula. So the sum of the first 18 terms. We have 18 terms. We divide it by 2. Then we take the first term plus the last term, and now use your calculator. That's the formula to add an arithmetic series. Does that formula feel familiar to you? But I know that you're not a robot, so what you don't practice, you're going to forget. So let's go this again. Number 2. Is number 2 an arithmetic series? And the answer is yes, because the common difference is negative 8. I know the first term is 50, but I don't know, and I know how many terms there are, which is 35. What don't I know is the last term. So in order to find the last term, I need a rule. And the rule will be negative 8, n minus 1, plus 50. Once you have the rule, I then plug in 35 to find the last term. You can use your calculator. Did you get negative 120? Is that right? Oh no, I typed it in wrong. Let's try it again. Negative 222. Now, the formula. So I want to, S stands for sum. So I want to add the first 35 terms. So the number of terms is 35 divided by 2. Then the first term is 50. And the last term is negative 222. And then you use your calculator. All right, number 3. Can you add up this arithmetic series? Well, I know the first term is -4. I know that there are 21 terms in this. I know it's arithmetic because it goes down by -2 point, or is it, yeah, 2 point, or is it going up, right? So it's positive 2.5. So I need a rule. The more you practice, the quicker the rule is to write down. So the common difference is 2.5, and it's n minus 1, and the first term was -4. Then I need to find the 21st term. So you'd use your calculator to find the 21st term. Then, once you know that, you can just set up the formula. So the formula to find the first 21 terms is you take 21 divided by 2, and the first term and the last term you add together, and now use your calculator. So if anyone said, hey, can you add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all the way to 100, you now have a formula where you could add up 1 through 100 like that. You can try it out later. I want to add up 1 to 1,000,000. 1 plus and all the way to 1,000,000. And now you have a formula and not have to go 1 plus 2 plus 3 plus 4 plus 5. All right, number 4. In number 4, the first term is 1/10. I know I have 9 terms. The common difference, I'm going to have to subtract any two numbers together. So if I subtract, it will give me the answer. And you can use your calculator if you want. So -1 over 15, subtract 1 over 10. With common denominators, it'd be like 30, wouldn't it? So it'd be -2, subtract 3, so -5 over 30, which is -1 over 6. Again, you're allowed to use your calculator. Now I need a rule. So the rule is -1/6, n minus 1 plus 1/10. I need to find the 9th term. So I plug in 9 to find the 9th term, and just be comfortable with your calculator. Once you know the 9th term, then the formula you set up. So to find the sum of the 9 terms, it's the number of terms divided by 2, then the first term and the last one, and then use your calculator. Number 5. When it's in sum notation, it's way easier, or sigma notation, because all the information you need is quickly to get. So what do I need to know? Remember how we found out how many terms there are? What do? Top, subtract, bottom, and then what? Add 1. So if I go from 1 through 10, how many terms are there? 10. How do I find the first term? Plug in 1, and the answer is 7. How do I find the last one? You plug in 10, and the answer is 61. It's quick to get all the information you need, and then you add up the first 10 terms. So you take the number of terms divided by 2, then it's the first term plus the last term, and use your calculator. All right, try number 6. This will be the last one on the video for right now. I'll continue it today during my prep and finish it, but we're going to work on this tomorrow too. There will be a quiz on it, but we'll still work on it first. Number 6. So how many terms do we have if we go 1 through 24? Can you find the first term? Plug in 1, and what's your answer? Negative 69. Plug in 24. What's the last term? You might need a calculator. Negative 48 and negative 67. Negative 115. That's all I need. And then the next is, do you know the formula? So to add up the first 24 terms in an arithmetic series, what do? How many terms do you have? Divided by 2, and then you take the first and the last, and there's your answer. The best way to remember a formula is by practicing it, not just by looking on a flashcard. All right, so there's your lesson on series. A series is a sum of an ordered pair, set of numbers. And if it's arithmetic, we have a formula we can use for that. All right, Mr. G Math. Part 1. Over now.